Hello students, this is Ms. Dalton. Now we're going to look at graphing linear inequalities. So our objective is that the learner will graph linear inequalities and decide if points are solutions at the end of this lesson. A linear inequality is written in slope-intercept form. I'm going to abbreviate intercept. And remember, that's, if you remember correctly, that's just y equals mx plus b. But the equal sign is going to be replaced with inequalities. And if you remember what those are, that's the less than, the greater than, less than or equal to, or greater than or equal to. All right, so we've typed up some steps to the graphing linear inequalities. So let's follow along with what it says. It's the very first step, you're going to put the inequality in slope-intercept form, which means you are going to get y by itself. Another hint, make sure that you remember to flip the inequality if you multiply or divide by a negative. That's very important. The next thing you're going to do is decide on the type of boundary, or decide on the line that you're going to draw. If the inequality is less than or equal to or greater than or equal to, they have the line under it. So you're going to use a solid line because some of the solutions, because all of the solutions, or some of the solutions are on that line. There are other solutions that will be either below or above that line, but some of them can be on that line. Okay? If the inequality is a less than or greater than, that means it can either be less than or greater than, but it's not going to be equal to, so we're going to use a dotted line because the solutions, the points that are on that line, are not solutions. Then you're going to replace the inequality symbol with an equal sign and use the slope and y-intercept to graph the boundary line. And then the last step is to shade. And I'm going to actually show you two different ways on shading. This first way says select a test point such as 0, 0. And if it is true, if it is a true statement, then you will shade that region that contains the point. If it is not true, then you will shade the other region. So let's do one example just so that you can see what I'm talking about. This first example says 2x plus 3y is less than negative 3. So our very first step, we need to get y by itself. So we're going to subtract 2x, and this, you should be getting good at this because we've been doing this for a while now. It's just like getting your y by itself when you had a linear equation. You'll have 3y less than, you just bring that down. Then you always want to put the x value first, so negative 2x and then minus 3. Then we're going to divide both sides by 3, divide by 3, divide by 3. Notice I did not divide by a negative, so I don't need to flip my inequality. This inequality is going to stay exactly the same. If I had divided by a negative number, then I would flip my inequality. My slope then will be negative 2/3. Put the x there. And then negative 3 divided by 3 is a minus 1. Okay, so the negative 2/3 represents my slope. And then my b value is negative 1. Okay. When we graph this line, we want to look at this inequality. Because it is a less than and it does not have a line under it, then we're going to make sure that when we graph this, we're going to use a dotted line. To graph it, you want to graph it just like you would a linear equation. You begin with the y-intercept, so you graph that on the y-axis at negative 1. Then you're going to go down 2 and over 3 to get to the next point. When you draw your line, you want to make sure that it is dotted. So we make it kind of dashed. Again, I realize that my line's not really going through those dots very well. Now you want to decide where you're going to shade. Now, in these instructions it says take a test point, such as 0, 0. Okay, 0, 0 would actually be, let me redraw this line real quick. I don't think I did a very good job, so let's redo that. -1, and then down 2 and over 3, approximately here. The reason why I wanted to redraw it is because that 0, 0 is actually above that line. So let's use that test point. If I plug in 0, 0, and I could do that right here. So if this was a 0 and this was a 0, this would be 0. So it's saying that 0 is less than -1. Well, 0 is not less than -1, so I do not want to shade this up region up here. I want to shade below this line. So when I shade it, I'm just going to color in this region. Okay, it doesn't have to be perfect. You're just shading where this would be. Okay, now the way that I remember it, because I think that's a little time consuming, the way I remember it is this is a less than symbol. So you're going to shade less than that line. So what I always tell students to do is put your pencil on the line and then draw straight down. If you draw straight down, you're going to be able to see exactly which side of that line you're going to shade. Let's say I had another line. Let's say it was like this, and I needed to shade greater than. Well, again, put your pencil on the line, and if you shade up, you're going to see that this is greater than. Now, some people get confused because they think, well, this is less than, but this is greater than, and they're shaded on the same side. You don't want to look at it that way. You want to look at, am I shading above the line, or am I shading below the line? And that's all based off of that inequality. We'll do some practice on this tomorrow. Just make sure that you have your notes filled in and that you have your whisk filled out.